Hello and welcome to securing Nvidia Triton Inference Server with Nginx Ingress Controller. My name is Greg Coward, and over the next few minutes, we'll walk through deploying a sample Kubernetes application highlighting how Nginx Ingress Controller can provide secure and scalable external access to Nvidia's Triton Inference Server. The demo application resources are located on GitHub under F5 Dev Central, Triton Inference Server, and Nginx Ingress Controller. This repository provides a working example of how Nginx Ingress Controller can provide secure external access as well as load balancing to an Nvidia Triton Inference Server cluster. The repository is based on forks from both the Nvidia Triton Inference Server repo and the Nginx Ingress Controller repo. The included README provides detailed guidance for all the steps we are about to perform. To start with, I'll need to clone a local copy of the repo. I'll use VS Code to clone, configure, and to deploy. Let's take a quick look at the contents. The repo includes a Helm chart along with the required resources for deploying the infrastructure. In addition to the deployment files, I've included a sample model repository as well as a sample Python script I'll use to test connectivity later. I'll do a quick check on my Kubernetes cluster, more specifically my AKS cluster. Currently, all I have running is a simple NFS server that is hosting my model repository. Next, I need to create a Docker registry secret to store my Nginx Java Web Token. This is required to pull the Nginx instance from the private repo. I also need to create a Kubernetes TLS secret to store my service certs and keys. The Triton Inference Server exposes multiple endpoints, and I'll use separate host names for each of these services. I simply combine the relevant certs and keys into two separate PEM files and reference them to create the secret. As I mentioned, I have included the sample model repository in the repo. To save time, I have already deployed an NFS server and imported the sample files. You can use any reachable NFS server to host the model repository. Additionally, in case you don't have access to an NFS server, the README includes step-by-step instructions for deploying and prepping an NFS server in Kubernetes. You will need to modify the values.yaml file for your deployment. This includes specifying service FQDNs, whether you want to enable auto-scaling, and the location of the NFS server hosting the model repo. I can also enable additional security functionality, including Nginx App Protect and App Protect DOS. Next on the agenda, I need to import and deploy the Prometheus and Grafana Helm chart. Prometheus will collect the Triton server metrics, which will be viewable in Grafana. I'll take another quick look at my Kubernetes services, and yep, a whole bunch of additional services have been deployed. Okay, time for the main event. I'll use Helm again to deploy the Triton servers along with the Nginx Ingress Controller. Yep, just that fast. I'll need to take note of the Ingress Controller's external IP and update my DNS records accordingly. While my DNS is updating, let's take a look at the Nginx dashboard. To do that, I'll first need to configure port forwarding from the Ingress Controller pod to my local host. Likewise, I need to configure port forwarding from the Grafana metrics service to my local host. With that done, let's head back to the browser. I can see that my Nginx Plus Ingress Controller appears to be configured correctly, and the expected Triton services are registered and ready for traffic. For Grafana, I've included the sample Triton server dashboard. After I log in, I simply need to import the dashboard from the repo, and I can start viewing Triton metrics. I've included one of Nvidia's sample Python scripts for testing connectivity. Let's run the script. The script makes an inference request over HTTPS to the simple model and returns various metrics and calculations. I'll run it a few times to generate some traffic. Back on the Grafana dashboard, I can refresh and see metrics related to my request, including to what model they were directed. Check out the following links for additional information related to this demo and the related technologies. My name is Greg Coward. Thank you very much.